welcome to our training session today. It is on the use of a multimeter. As you know, you're going for the maintenance manager role in the company, and you need to know how to use a multimeter and some of the functions of it. Not all of them; they're very complicated multimeters, but some of the basic ones you'll need to know. I think you've already identified one.
Yes, it would be very helpful. We use, for example, elevated work platforms, scissor lifts, and they contain a couple of batteries in them, and often one of them or both of them won't take charge, and I need to know which one it is. So it'd be helpful to have some skills with the multimeter.
Excellent.
To identify which battery, if not both, isn't taking a charge.
Okay.
It becomes an issue of safety.
Okay. Well, that's good. You've already identified a practical use for the knowledge that we're just going to go through, or the tasks we're going to go through. Before we start, we've got water just inside the next room to us, and also the toilets just inside the glass doors. So,
thank you.
Now, are you comfortable? Are you ready to go? It's
Yep.
a 20-minute session,
Yeah.
no breaks.
Yeah, thank you.
We'll just go through any questions you have along the way. Please just ask away. That's why we're here.
Thanks, Wayne.
Alrighty, so what we need to do first is to get a little bit of electronic theory or electrical theory under your belt, so it makes sense when you're testing with a multimeter. You know exactly what you are testing and what you are testing for, what you expect to see, and then what you do see. Sometimes they're two totally different things. So firstly, we need to look at the two types of power that you'll be exposed to. One is DC power and one is AC power. So I've got some reference material here that sort of pictorially shows you a little bit about AC, DC and some other things. I'll leave this with you so it can be a reference tool for you. Difference between AC and DC voltage. So now some of this you may already know, but we're going to go through it anyway just to make sure that all bases are covered. So the basic two differences are with a DC voltage, as you can see in this diagram, the negative and the positive remain that way all the way through. No matter what you do with a DC voltage, the negative and the positive are always aligned. Okay. In AC voltage, it's a little bit more tricky in that the negative and the positive changes over time. They swap backwards and forwards. That's why you can see on this curve here that they are swapping the whole time. In Australia, we swap the negative and the positive 50 times a second. That's why it's called 50 hertz, 240 volt 50 hertz current. It swaps this negative and positive 50 times a second.
Is there a reason why it swaps?
It's purely because it's an alternating current. To be able to get enough voltage to do the work required, AC is a good efficient way of doing things. If we had to try and get the same voltage out of a DC current, it would require a lot more power to generate that voltage. So AC is a very efficient, effective way of generating a very high voltage easily. So we can also, this is not part of what we're doing, but the 50 hertz, as you've brought up, it can also be used to time things. It's very, very stable AC current. So you can actually use that 50 hertz, that 50 cycles per second, as a timer for various electronic bits and pieces. So that's not what we're discussing today, but it's just an interesting thing about AC. DC is what we'll be looking at today, direct current. Positive, negative always remain the same. That also is another diagram of alternating current and direct current. Now what we're going to also do is have a look at current itself, not just voltage. Current is an unusual thing, and sometimes it's a little bit difficult to understand, but again I've got some diagrams here that may help you. We go back to a water analogy, it's probably best. The water itself is our voltage. That's our DC voltage. It could be 12 volts, it could be 24 volts, whatever. The water itself is the voltage. The amount that we turn the tap on is the current. We have voltage sitting there, constant, 12 volt or 24 volt, but the amount that we allow out is the current. The current actually does the work. The voltage is the potential to do work. You know, if we let it all out at once, big potential. But the potential is always sitting there. The current is the amount of work that it will do. So again, I've got another diagram over here where we've got the voltage trying to push this little guy through this tube here. We've got someone else here with a rope on it, tightening it up, and he's not allowing all of the current to go through, all of that voltage. He's squeezed it down so only a small amount comes through. So that's the relationship between a voltage and a current. And if I still reckon the water one is the best. The water is the voltage, and how much you turn the tap on is the current. So that's a little bit of theory that we needed to go through just before we started looking at the multimeter. So what we'll be doing is looking at voltage, we'll be looking at resistance, the resistance to that voltage, what's stopping that voltage getting through, and that again is like that tap arrangement, and also capacitance. We'll be looking at capacitors. If you're testing basic componentry and circuits, capacitors sometimes are the tricky guys. If you have a capacitor that goes out, it will stop a 12 volt supply from working. Right. They're the first things that you try when you're getting no voltage. You try the capacitors. They're usually the culprit. So we're going to do a little bit on capacitance, and also we're going to do the continuity testing. Does the signal get from this point to this point? If it doesn't, we know we've got a problem in the middle here. So we go backwards and backwards and backwards until we find the problem. So with very basic electronic circuits, which you will need to be able to test within your new role, continuity is something that will come up again and again and again. So we're trying to get the main food groups for you here, and just go over a few different possibilities, a few different ways of doing things. Now this is a standard multimeter. It's not a real cheap one. It's not a hugely expensive one, but it has a number of settings on this dial here. Of course, at the minute it's on off. There's nothing on the screen. We've got the first one, which is a V sign, which would mean, what would that indicate to you?
Voltage.
The voltage, very good. And those lines next to it, would they make any sense?
Yeah, it looks like a bit like your direct current from what you said before.
From our diagram?
From our diagram.
Yep. And the squiggly line on top?
Well, that could also be your alternating current.
Correct. This multimeter doesn't have a separate switch for DC or AC.
Okay.
It will actually work it out on its own. Very clever. Some do, some don't, all depending on which multimeter you're on. Go up to the next one. Now we've got millivolts. M for milli and volts, so thousandths of a volt. And again, DC, and again, AC. It will do both. It will work itself out. We're going to skip this one here. We're going to go straight to this guy. Now this guy is in a circular pattern. As you cycle through the functions, it goes around the circle clockwise. So we start off with, that's the omega sign, or ohms, which is for resistance.
Okay.
The next one along, with an arrow with a little line at the front of it, is for a thing called a diode. We won't be having to deal with that today. We'll actually have a look at one, but we won't need to test it. The next one, it looks like a sound thing. You know, there's sound sort of emanating from it. That's exactly what it is. It has a buzzer function. So you don't have to keep looking at the screen to get a result. You get a result by the buzzer.
Right.
we'll explore that a little bit later as well. And the final one there is like two little lines side by side, and that's for capacitance. That's for testing capacitors. We've got some capacitors here. We'll have a look at those too. So what we'll be doing mainly is using the voltage switch. We'll also go to resistance, and we'll go to capacitance. So we're going to use that setting as well. The rest of them at this stage don't really need to worry about. It's just that one and that one there. Okay. So let's have a look at resistance. Now automatically this goes to a mega ohm. That's the largest resistance that it can measure. But it's auto ranging in that if you give it something that's much smaller than mega ohm, it will automatically pull the display down where the decimal point is and show you, is it milliohms, is it ohms, kilo ohms, or mega ohms. It will automatically sort that out for you, and the symbol will change as well.
What sorts of things would be sort of mega ohms and then milliohms?
Mega ohms, you're looking at very big power supplies. It would be measured in mega ohms. You'd have resistors in there that are absolutely huge.
Right.
Could be the size of this table. Could be mega ohms. Mainly we deal with milliohms and ohms. That's mainly where we go. Kilo ohms, no. Mega ohms, no. Not in the area that we'd be looking at, or you'd be looking at.
So you're looking at circuitry and stuff.
Yeah. Low voltage, low amperage or current would be the lower range of ohms. So, for instance, if you had a speaker out of a hi-fi system, it should read 8 ohms. Most speakers are 8 ohms only. So that gives you an idea of the scale we're looking at. So, for instance, we're looking at, let's have a look at something here that could give us some resistance. I've got here a here's some resistors, and these resistors are sealed very, very well. They come like this, by the way, in packs with tape on them. So all you've got to do is snip and take that away. Sometimes, as you can see with this lot, there's a lot of resistors sitting there, so you don't have to peel the tape off, you just cut however many resistors you need. Now this resistor, we don't know its resistance as such, so we take it out of there, and now we're going to measure it. So let's stand this up with its little stand here so we can see.
Clever.
It's quite clever. So we are on resistance. We are at mega ohms. So anything less than that, it will just move the decimal point down.
Oh yes.
So put one probe on one side of the resistor and one probe on the other side of the resistor.
Does it matter which side?
It does not matter.
Doesn't matter which colour it...
Doesn't matter which colour, doesn't matter which side. Not with a resistor, no. Okay.
100.3.
What's the decimal?
That's
just ohm?
Ohm.
So 100.3 ohms.
Ohms.
There you go. It's automatically worked out that it just needs the ohm range. And there we go.
100.2 ohms.
Yeah. It might fluctuate just a little bit. So what that's actually doing is it takes 2 volts out of the multimeter and it puts 2 volts across that resistor. So it goes 2 volts in one end, and it measures whatever it comes out the other end.
And what's the purpose of the resistor? Obviously to resist, but resist what?
To resist it, it actually makes the current do work. So you might have to say, okay, it's 12 volts at 1 amp, which is the current. It's measured in amps. Has 1 amp. We need to bring that down to maybe half an amp to make it work properly for us.
Oh, okay.
So you put some resistance in the line, and
gotcha.
that drops it down to half an amp.
I gotcha.
So it basically soaks up the power that you don't need.
Okay.
Yeah.
Is it a bit like that tap, sort of, it holds
Yeah.
the pressure?
Just like the tap.
Oh, yeah.
Just like turning on a tap.
Oh, that's good.
Yep. So that's resistor.
So that's ohms.
So that's ohms. We're looking at ohms for resistance. And of course they all come in different flavours, different sizes, different values. And the other thing about resistors is, if we have a look over here, you can double check what you find with a multimeter with the colour code for a resistor. So this, for instance, is a 4-band. So we can tell that it was, what was the initial measurement that we made?
So it's 100.
100.
100.2.
Okay. So we've got brown. The first digit is brown, 1.
Yep.
The next is second digit, which is 0. So we've got 1, 0. Now we've got brown. Now this is the multiplier. Whatever you get in the first 2 digits, you then multiply by the colour.
So it was 10,
Brown.
10 by 1, is it?
Yeah.
So you get 10 ohms.
10 by 10 is
Oh, yeah, multiply 10. 10 by 10 is, 100.
100 ohm. So that's a great way of double checking what you're getting out of your multimeter. Is it correct? Go back to the colour chart, have a look at the colours on the resistor and double check.
So that's working.
It's working.
Doing its job.
It's a perfect resistor. That'd be ready to go back into a circuit if you need to. You probably won't need to get to that point where you actually have to replace components, but if you can easily check a circuit, a simple circuit, nothing too complicated, if you can just check before you start saying, okay, it's dead or it needs to be replaced, it's a good idea.
Oh, yeah,
It's a good idea. So the next thing we're going to look at is capacitance. Now capacitance is as I said, is one of those things, especially in a power supply, that it's the very first thing to fail.
Oh, okay. Yep.
So when you've got just a simple power supply, just a 12 volt power supply, and you can get to it, you can actually take the case off and have a look at it. A capacitor is usually the culprit if it's not working. And a capacitor is sort of like a battery. It stores power, and it only releases it when the circuit needs the power. It's a great little gadget, and can be tested in a circuit. Sometimes you've got to take components off a circuit to test them. A capacitor you can actually test in the circuit. You won't be able to read the capacitance of this capacitor.
Sorry.
That's all right. That's the capacitance of this capacitor. But what you can do is, while we're on our resistance, we can actually put the probes across the capacitor, and you'll see initially the resistance is fairly low, and then it all of a sudden starts to grow, and it keeps growing and keeps growing. If it keeps growing, you know that 9 times out of 10 that capacitor is good. So let's try that.
It doesn't matter
which one. Again, all it's doing is putting 2 volts across it and measuring what comes out the other end.
Can I do something like this?
You can do that. All right, we'll watch the display. All right, let's watch it. See it rising?
Yes.
Okay. So we know that that capacitor is doing what it's supposed to do.
It's working.
Does it get to its full value? We don't know until we actually take it out and test it. But 9 times out of 10, pop the probes across the capacitor. If it starts to charge up like that, it's pretty good.
Another go.
Sure.
Yeah, cool.
So
That's
sorry,
that's capacitant.
that's
So we've
capacitance.
done resistance and capacitance.
Correct. And one of the other things that you will certainly need to do is continuity.
So that was what you said, from one point to the next.
Correct. Right. So we've got just very simple here. We've got a lead. We've got a red and a black, and we want to check to see whether or not there's a break in this cable. Now, it could be a very long cable. It could be a very short cable. It doesn't really matter. We need to find out if there's a break in there. If the power gets from that cable to that cable and that cable to that cable. So we're still going to use our resistance, which we're on at the minute.
Yeah, I see.
But this time we're going to use the buzzer function.
Right.
So that little function button there, if you push that twice, so you push it, yep, and again.
Oh.
See how it's got that little symbol up the top?
Yep.
Put the probes together,
Gotcha.
and there's the buzzer.
Okay, yeah. So once it completes a circuit, so to speak, it'll buzz.
It will buzz.
And if it's broken,
Won't buzz.
Roger.
The great thing is that you don't have to keep looking at the screen. If you're in an awkward position, under something or whatever, all you need to do is put it onto
That's
the
a good
buzzer
idea,
function.
isn't it?
So let's find out which of those 4 are continuous.
So
They have no breaks in them.
So got to go black and black.
So let's go black and black first.
Doesn't matter what.
Doesn't matter which way.
So
Great.
that's good.
Continuous.
That's
Continuous.
If I put the other one,
Let's make sure it's not a short circuit.
so
There you go. If there was a problem inside the cable and somewhere in the insulation those two were touching,
that
would buzz.
Would buzz.
You'd go, okay, we've got to shorten the cable.
Cool. That would have been handy. That's handy, like for work. We've got a trailer
Yes,
and we have issues with that. That'd be handy.
very handy for a trailer. Absolutely.
Find if there's a break in something
That's right. Yep.
in the wiring. I mean,
In the wiring, correct. So we've covered a number of things. We've covered our resistance, the opposition to the current or the voltage flowing. We've had a look at the 2 different sorts of voltages, AC, DC. AC voltage is probably something to leave to a qualified electrician or electronic specialist. It can be dangerous for a start. As you get more and more comfortable with using a multimeter, you can start measuring AC voltages, but at this stage, for this particular job, that's something left to a qualified professional to look at AC voltages.
Yes.
The types of DC voltages that you might be looking at are these guys here. These are just normal power supplies. 240 volts goes in one end, and usually 12 volts comes out the other end. So when we're on to our voltage setting over here, on this particular multimeter, it will do either DC voltage or AC voltage. So this one here would measure 12 volts coming out.
because it's a 12 volt.
It's a
It
12
says that
volt
on the back,
supply,
doesn't it?
and then you double check. Actually, yes, 12 volts at 5 amps. It's a fair amount of amperage. There's a lot of amperage coming out of that thing. So that's good. It's a 12 volt 5 amp. This one here is a 9 volt. Is a 12 volt at 0.4 of an amp.
So that
Not
restricts
much
it.
current. Yeah, that would be used on something that just doesn't require a lot of power. Still needs 12 volts, but very little current, very little power. So this one
Very
would
little
do
voltage.
correct. That would do more work.
So your current is your voltage, really.
The current is the amount of work the voltage will do.
Yes, and
Yeah?
then your tapping.
Correct. So 0.4 milliamp, still 12 volts. The potential is there, but not a lot of work's done.
Yeah, okay.
This one here, 5 amp, 12 volts, a lot of work done.
Mm-hmm.
Sort
What would
of, you
that?
That's a 4-cylinder car, non-turbo, and that's a V8 bi-turbo.
right.
You know,
So what would this one sort of be used for?
that would be used for something like perhaps a laptop computer,
Oh yeah,
something that requires a lot of
Power.
work to be done.
yeah. And this one more a phone or something? Or
Yeah, it could be a phone, could be a charger,
Charging light?
yeah, something
Yeah,
like that.
gotcha.
Yeah. So they're the sort of main power supplies that you would be checking for. These would be powering a circuit that maybe has now stopped working, and you'd like to find out why. Check the power supply first. Okay. Just make sure there is 12 volts coming out of the power supplies. Now you can start to work through and
Yeah.
check other things. If the unit has definitely stopped working, our friend the capacitor, have a look at the capacitors. See if they charge up using the multimeter. If they start charging up, and you can see it on the display, the capacitors are okay as well. You need to look elsewhere. Could be a fuse perhaps. That's where your continuity comes in.
yes.
If you've got a glass fuse and you put your probes on either end of the fuse, you can tell whether the fuse is
Yes.
good or not.
Yeah.
If it's not, there's your problem. It's blown a fuse. So we've gone through a number of things. As I said, I'll leave the reference material with you, so you can go back and have another look at this sort of stuff. I would suggest, if you've got access to a multimeter at work, to find some power supplies perhaps. Go around and test some of the power supplies, just to get used to using the multimeter. But it's basically voltage you're testing for, resistance, continuity, does the signal get through, and fourthly, perhaps capacitance if you really need to get down into a circuit. So, any questions?
Probably have more questions when I'm out there doing it rather than
Sure.
now. I mean, it was pretty clear what you've described.
Good.
We've had 3 things that we've looked at. We've just done voltage. We've looked at capacitors, and we've looked at the old resistors. So we've done resistance, capacitors, and we've also done continuity, and we've looked at the power supplies.
Correct.
So
That's
pretty straightforward once you know
Yes.
that.
once you know which
Which
setting.
setting that you're going
Absolutely.
for.
Absolutely.
And the good one is the one in terms of where it sort of beeped at you. Didn't know that before.
Yeah. With the
I
buzzer
didn't even
on it.
really know any of it before, to be honest.
Yeah. With the buzzer, it's really handy.
Yeah.
Especially if you're in an awkward spot and you can't always see the display.
Like I know I could have probably done the volts one, but I wouldn't have known anything about the others.
Great. Excellent.
Yeah, because V is pretty straightforward.
Good.
Yeah.
Good.
Thank you, Wayne.
Well, if you've got no further questions, grab a multimeter if you've got access to one, and just go around and try a few things. Make sure you're using low voltage. Keep safe. Don't look at AC voltage, 240 volts. Just leave that alone for a minute. But anything else like that, try with the multimeter. See how you go.
Wonderful.
Good.
Thank you.
You're very welcome.